Solving absolute value equations, the lesson, which could last anywhere from 30 seconds to get it done. That's all up to you. I stop when you start talking. Okay, I'm done. All right, solving. So remember the definition of absolute value. The absolute value of x is equal to x when x is greater than 0. Greater than or equal to 0, let's say. And the absolute value of x is equal to negative x when x is less than 0. So as an example, the absolute value of 5 equals 5. The absolute value of negative 7 is equal to negative. You take the negative of the value, which then gives you the positive value, right? So we get 7. Okay, so we want to solve both algebraically and graphically. Let's start with an algebraic solution. So solve algebraically. Most of the time you know it's going to be algebraically, right? Where you got to show your work, and also you can get exact answers that way, right? Graphically, you may get exact answers, but you may get answers to the nearest, whatever you want to round to. So let's say we have the absolute value of 3x minus 5 minus 4x plus 7 is equal to 0. Okay, so we want to solve that, right? We want to find what values of x make this true. So the way we do this is we're going to move this stuff over, right? We're going to isolate the absolute value. And we are going to say that the absolute value of 3x minus 5 is equal to 4x minus 7, right? Very nice kind of linear equation. But there's two possibilities, right? And that is plus or minus 3x minus 5 is equal to 4x minus 7, right? Because we know that there's two possibilities, right? You take the positive of 3x minus 5 and you try and solve it for 4x minus 7. And then you take the negative and you try and solve it. But then you have to check both answers, right? Since because of the absolute value, it's easy to introduce extraneous solutions. Okay, so we're going to solve two equations. We're going to solve 3x minus 5 equals 4x minus 7, which gives us what? 2, right? X equals 2. And we are going to solve the negative of 3x minus 5 equals 4x minus 7, which means we're going to distribute this negative through, get negative 3x plus 5 is equal to 4x minus 7, giving us 7x. Right, equals 12, and x is equal to 12 over 7, right? So we have two potential solutions, right? Is it 2? Is it 12 over 7? The only way to know is we have to check, right? So we now check for extraneous solutions. So in order to do that, we go back to the original, right? So the original equation, I'm just going to do a left side, right side check. The original, the left side is equal to the absolute value. And by the original, right, the original, 3x minus 5 minus 4x plus 7. And the right side is equal to 0. That's the original equation, right? Before we rearrange. Because if you make a mistake rearranging, you will now have solved a different equation and probably have the solution to that different yet wrong equation, right? So we need to check. So we think that x is 2. So everywhere we see an x, we're going to put in a 2. And what do we get out of this? 1. So we get 1 minus 8 plus 7, which is equal to 0. So this one does check, right? So 2 is a solution to the equation. And now we're going to do the same thing again. Oops, minus 4x And we're going to do that with 12 over 7, right? So we've got 12 over 7. So it's the absolute value of 3 times 12 sevenths minus 5 minus 4 times 12 sevenths plus 7. So how are we going to do this? What do we want to do? No. Calculator. We're going to convert everything to have a denominator of 7, right? Because it's sevenths all around. So this is going to be 36 over 7 minus, what's it? 35 over 7 minus 48 over 7 plus 49 over 7. So what's this work out to? 1/7 minus 48 sevenths plus 49 sevenths, which is equal to which is not 0, right? So that's an extraneous solution that was introduced by our method of solving, right? So the solution x equals 2, or the solution set is the set consisting of the number 2. Any questions on this particular one? Nope. Okay. Now, we could do this graphically as well. Do you want to take a look at what the graph of this looks like? So we'll just go into decimals and do it, right? Come on. Okay, so what do we want? We want the absolute value of 3x minus 5 minus 4x plus 7. And what are we looking for? Looking for the 0, right? We're looking for where that switches at 2. So, and I think if we zoom out, we're just going to see that this graph is just going to, kind of keep going the way it's going. Okay? What else could we graph? We could graph the absolute value of 3x minus 5. Whoops. Let's go Control Z. And then we could graph. What else could we graph? 4x minus 7. And we could look for the intersection of those, which we should kind of zoom in. Let's just go back to. Right, and we can see that happens at 2. Okay, so it's graphical solution, or it's also graphical verification, right? I mean, maybe you made a mistake in the algebra. You can also check this graphically. Now, you don't do that until the end of the test, right? If you're writing a test, then at the end, you can go back and check with your calculator. Unless you're writing that section of the IB exam where you're not allowed calculators, in which case you really don't even have to worry about it then. Okay, example 2. Let's solve this one graphically. So here we've got a double absolute value, right? We've got the absolute value of x plus 2 minus the absolute value of x minus 3 is equal to x minus 1. So in this, we'll graph y1 is ABS. It's more of an uppercase X, isn't it? Minus ABS. And in y2, we will graph x minus 1. And then we will find the intersects. Okay, so turn this on. So we got y equals, so ABS, it's under math and then over to num. That's where ABS is, right? And on the 84, then of course you see the fancy absolute value bars. If you have an 83, then you'll see brackets there. Minus math, num, ABS, and we want x minus 3. And down here we want x minus 1. X minus 1. Now it's a straight line, right? We know x minus 1 is a straight line. We'll graph that in the standard window. So there's the absolute value graph. We seem to have 3 crossing points. Here, here, here. So we can do an intersect. You know, it's easier to move along the straight line, so I'll just go down here. So 1, 2, 3. So we have -4. Remember, we're interested in the x coordinates of the point of intersection, right? So we have -4. We have what looks like 0. 0. And we have 6. 6. Okay, so -4, 0, and 6. Okay, so our solution set is those 3 numbers, right? Okay, how do we solve this one algebraically, right? Oh, and also, what other alternative could we do graphically?
Flip it over and the graph's in the middle.
Yeah, so we move it all to one side, so we could do this and then just go -x plus 1. Okay, and then just not graph, just clear that out. And then what are we looking for?
The x-intercept.
Yeah, we're looking for the zeros or the x-intercepts, right? And we can see them there. You might actually be able to see them out of the table as well, right? We're just looking for when is y 0, so 0, 6, -4, right? So if they're nice answers, right, like integer answers, then you can pull that information out of the table. You don't necessarily have to do the second calc intersect. If it says rounded to the nearest 10th or 100th, then you know you're pretty much looking at values which may be exact values and have to be solved as such. Okay, how do we do an algebraic solution? With a double absolute value. Let me guess. I didn't even need to look to know.
You actually need to check that.
No, I didn't. I just sort of thought, oh, Mohit's here. I'll write you a note. Mohit, are you 16? I'll write you a note. Buy him a car so he can get here on time.
Are you getting him probably get into traffic every single day?
Well, you know,
Accidents.
but have less of an excuse.
Okay, like that.
Okay, so how many possibilities do we have here that we have to examine? I think more.
4.
4. Very good. What are the 4 possibilities?
Plus or minus x plus 2 or plus or minus x minus 3.
Yeah, so we have a positive x plus 2 with a positive x minus 3. We have a positive x plus 2 with a negative x minus 3. We have a negative x plus 2 with a positive x minus 3. And we have a negative x plus 2 with a negative x minus 3, right? Since there's 2 absolute values, there are 4 possibilities for distributing the signs, right? Since we know that part of this graph is positive, like when x is greater than or equal to -2, this is positive. When it's less than -2, this is negative, right? And so we need to adjust it upwards. So we have those 4 possibilities that we have to examine, right? So we can examine 4 possibilities. Just be glad there's not 3 absolute values, or how many possibilities would that?
12 or 8.
8. Yeah, we'd have 8 possibilities if there were 3 absolute values, right? Because any one of them be 2 to the power of 3. Yeah, so it's 2 to the power of n, where n is the number of absolute value
We should have a bonus question.
things that you have. Yeah, we should do one with like 6 of them.
God, no. That'll be the bonus question.
Examine all 64 possibilities. Okay, so the first possibility is both of these expressions are positive, right? So x plus 2 minus
It's like the first time.
x minus 3 is equal to -1. So what do we get here? We get x plus 2 minus x plus 3 is equal to x minus 1. That's what? 5 is equal to x minus 1. So what's x? 6.
Yes.
Okay. Now, Does it mean x is 6? Well, we know it is because we've already solved it graphically, but we don't know, right? That's a possibility that needs to be verified.
We check all of them too. Oh.
Well,
Or you can fail.
yeah, well,
Or you can just no, we're going to check one
we-
and get the rest of it.
okay, this is the part of the IB exam where you don't have a calculator, so the only way you have to do this is algebraically, right? So you are going to have to verify it. Okay, what's the next possibility? The first expression is positive, and the second expression is negative. So it's minus the negative of x minus 3 equals x minus 1.
I see two reactions.
So this becomes x plus 2 plus x minus 3 is equal to x minus 1. 2x minus 1 is equal to x minus 1. So x is equal to 0. Okay, so that's another possibility, right? Again, we don't know. Okay, what's the third possibility? A negative. Do you want to do a negative and a negative, or let's do a negative and a positive?
Does it really matter? You have to go through all
It really doesn't matter.
I would get used to doing it so if you're going to do 4 of them, then I would get used to doing it just a certain way. Just pick a way so you always do it that way.
I just got
Right.
to
I like plus plus, plus minus, minus plus, minus minus. Doesn't matter. You just have to do all 4.
I'm going to do the same thing I do.
Okay, so negative x minus 2 minus x plus 3 is equal to x minus 1. Negative 2x plus 1 is equal to x minus 1. What do we get? Negative 3x is negative 2, so x is 2/3. Which we already know isn't one of the answers, right? But only because we did this graphically. Otherwise, we have no clue, right? We don't know.
In other words, you have to check all off the
And 4, both negatives, right? So negative on the x plus 2 minus negative. Having more fun than we are.
What are they doing?
I have no idea.
You're watching a movie.
It's like very excited.
Oh god. How would you even say that? It's the possible rational zeros.
X equals
We would obviously
negative 4.
Yeah, you can all be
So bad.
Okay, so we have 4 possibilities, right? Right? There are 4 possible.
I'm gonna go back and check all of them.
So you need to check all 4 possibilities, or at least be aware that you need to check, right? Or examine somehow. So if it's a multiple choice question, even if you don't, excuse me, even if you don't have to show your work, you either just do it straight graphically, right? Or, you know, again, if it's multiple choice but you don't have a calculator handy, you do it algebraically, you still need to run the checks. And, you know, you can do them mentally, kind of, right? You can just throw a 6 in, right? We're going to show them all formally, but, you know, you can, you know, you just keep in mind, you have to check.
Are you gonna have another time doing
Okay, so check.
Oh god.
So the left side is equal to the absolute value of x plus 2 minus the absolute value of x minus 3. And the right side is x minus 1. And the first value we're going to check is 6. So what I'm going to do is I'm just going to kind of do this in one thing, right? Not write it out 4 times, but just sort of we'll do the check of number 1. We'll say whether or not it's equal. We'll draw a little wavy line. We'll do a check of number 2, and then number 3, and then number 4. We'll just keep it all in the same thing here, right? So 6 plus 2 minus 6 minus 3, which is 8 minus 3, which is 5. And this is 6 minus 1, which is 5. So left side equals right side. So we have a valid check on number 1. Okay, number 2 was what? 0? So number 2, that's equal to the absolute value of 0 plus 2 minus the absolute value of 0 minus 3. which is 2 minus 3, which is negative 1. And over here we get 0 minus 1, which is negative 1. So we have a valid check. Let's just slide this down. And number 3 was what, 2/3? So equals 2/3 plus 2 minus the absolute value of 2/3 minus 3. So what's 2/3 plus 2? 8/3?
2 and 2/3. Yeah, 8/3.
Minus,
Minus 7.
it's the absolute value of 2/3 minus 3. So 8/3 minus 7/3, which is 1/3. And here we get 2/3 minus 1, which is negative 1/3. And so, no, that one does not check. And we go to 4, which is, what are we checking? Negative 4. So negative 4 plus 2 minus negative 4 minus 3. What's the absolute value of negative 4 plus 2? 2. What's the absolute value of negative 4 minus 3? So we get 2 minus 7. So we have 3 verifications, right? And we know that x is negative 6, 0, and 4. Or, where's that? Was it negative 6 or positive 6? Positive 6, right? So negative 4, 0, or 6. Or the solution set consisting of the values negative 4, 0, and 6. Okay, let's do one more, and I'm just going to show you an alternate method. Okay, so we know that whatever the result of this is, it has to be positive. If that said equals negative 4, then you could just call a halt at that moment, right? And say 2 positive values added together will not give a new negative value. There is no solution to this, without going into great detail. Okay, like if that had been negative 4, you just say, hey, no solution. Why? Because each of these is an absolute value and they're being added together, therefore the result must be positive. This is negative. There's no values of x that will do this. But we have how many possibilities? 4, right? And I'm going to start off with both positive. So it gives me what? 2x equals 4 and x equals 2. And then I'm going to do one positive and one negative. So that gives me 4 equals 4.
No.
Okay? So there's no solution, right? There's no x values that make that true. The statement itself is true, but not terrifically helpful. And we're going to do a negative with a positive. So that's negative x minus 2 plus x minus 2 is equal to 4. So what's that work out to? Negative 4 equals 4. Oh, sorry, hang on. That's not no solution. That's every solution. That's true for all values of x.
Wow.
It's negative 4 equals 4 has no solution. So it's true for all values of x, but we need to look into this further. But we need to look further. And what are we doing? Both negatives, right? So negative x minus 2 minus x plus 2 equals 4. Negative 2x is 4. X is negative 2. Okay, so what are we going to look at here?
Stuff. Namely number 2.
Did you say blueberry?
So we've got values of 2 and negative 2. We can see that, well, I mean, let's go back here and check. If I put a 2 in here, I get 4 plus 0, which is 4. So the 2 does check. The negative 2 gives me 0 and 4, so the negative 2 checks. But this one says, hey, it's true for any value of x, right? But we have to figure out which values of x. So what we're going to do is we're going to examine x plus 2. We're going to examine x plus 2 in the sense of the number line and say there's a critical point at negative 2 and say that all values above negative 2 will be positive. Right, for x plus 2. Not the absolute value of x plus 2, but for x plus 2. All the values above negative 2 will yield a positive, and all the values below negative 2 will give you a negative. And now we're going to look at x minus 2. And where's its critical value? At positive 2. And what do we know about all values that are above 2? And what do we know about all values that are below 2? I don't know why I put a 1 in there. I didn't mean to.
There's a gap.
Mind the gap.
Well, not on subway.
Okay, so what do we need here then?
Go for it.
So what do we need? Because we said any value of x, right? There's a solution where any value of x. Well, let's take a look then. Any value of x. If x is, so we've got places we can look, right? We can look above 2. Above 2, we know they're both positive. So if x is above 2, what's going to happen in the original? So pick any number, right? Because we said this is true for all values of x, but it's not really true for all values of x.
It's like.
What if x is 10? 10 plus 2 is 12. 12 plus 8, that's not 4. So I don't think it's going to work for any values of x that are above 2. Let's try 3. 3 plus 2 is 5. I mean, that's already too much, right? Because we know that we're just going to add on another positive number, right? So that'll be too big. What if x is 0, though? What if it's in this interval? What if x is 0? What do you get? You get 2 plus 2, which is 4. What if x is 1? 1 is also in the interval. What do we get?
4.
We get 4. What if x is negative 1?
4.
We get 4. What if x is negative 2? Well, we already know that one works, right? What if x is negative 3? Then what do we get?
Sorry, 4.
Not 4, right? Because negative 3 minus 2 is negative 5. It'll be too big. So which values of x do we have a true statement for? Yeah. So in this region from negative 2 to 2, right? So negative 2 less than or equal to x less than or equal to 2. In that region, all values of x make this thing true. So two of our solutions gave us the boundaries, right? They gave us the 2 and the negative 2. One solution just said, hey, there's values of x out there for which there is no solution. And one solution said, hey, there's values of x out there for which everything is a solution. But those values are restricted to be between negative 2 and 2. Right? Because basically, what do we need? we need one of them to be positive, while the other one is negative, right? Because the negative value, negative value on this is just going to make a larger number than -2, whereas it's going to take this one down in value, right? Make that smaller. Okay, so that's our solution to this particular thing. Can we do this graphically?
Yes, I think. Yes.
So what are we graphing? Let's try it. Let's try it on here.
It's most,
Yeah, I like this better, right? So
it's reliable.
You're so cool. That's what you think until you find
ABS x plus 2
The middle of the peak.
plus
It's going to be square.
ABS x minus 2.
It's a trapezoid. It's a trap.
Yeah, well, what we're interested in is when is it 4, right? Well, from here to here.
It's a trapezoid.
From -2 to -2.
From -2 to +2, right? Inclusive. I don't know if we could say equals 4 and have it solve in a... No, I guess not.
You can put 4 on the other one.
Yeah. I should have actually put y equals on this. I never did, but I think it just assumes
It's a
Yeah, I don't think it cares.
4. And if I do that, I should be able to pull... Whoops. I should be able to pull these points of intersection, right? Well, actually, I guess every point along here is a point of intersection. So.
Basically,
Yeah. Okay. Well, if you could do something where it checks equality, but... okay, done.